going in and going deeper. Day 22, let's go. We actually get hands-on now. Dependable, yeah, that's all overkill. No, something current to the actions, step summary. So looks like we only gonna do number one is done already. Build plus test workflow. Number two, code cow. It's fine to use it. Coverage gaze report, yeah. 3A it's fine. 4 it's fine. Everything else is not sure. Yeah, looks like it's actually nothing to do cleanup much. Let's just move documents and delete MD documents that's already been done, like session handoff and so on. And the other player tag visualization plan and cell type registry moves it into the agency, like to the to-dos and decision made or something like this, so we know for the sub-agents what to start next. I need to figure out how to new chat. Biology. Walk me through the stages of life cycle of the cell, like how it's born from division, I guess, right? And then how it grows, what stage it goes, and then die. And let's take it from a quiz perspective, so you can understand where my gaps are, and then you can one by one cover that gaps with explanation, and I'll try to recoup that knowledge. Be very significant, very scientific, very accurate in terms of biology. Don't just guess or give some kind of funny slang. Be brief and precise. If I need more explanation, I will always ask why on certain terms. But I want to show you. So we are hands-on, and take a look at this. We have our simulation with the cell division, the first one after. It's working. the very first one. Obviously it sticks. Go. Oh shit. Should not be here. Where did I ask that question? Oh, the Lisp. I remember that. Normal distribution. Okay, let's merge it. What's Parkrun? Yes. Okay. Cycle total random phase. That's interesting because I actually want to give me 1 second. Oh, 639, 681, 643. Okay, I didn't know it's fluctuated that much. I'm really not sure about that. Wow, this is very important. That's one of the, like, it's a key. Oh, hold on. Perturbation?
Perturbation.
Perturbation.
Perturbation. Paracrine.
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 Paracrine. I need to like get some visuals.
Cholesterol circulates in the bloodstream and then enters.
Oh, by the way, this is so dope video. Did I like it? Yes, I did. I'm gonna save it. Is that? Here we go, Michael Levin one. So long ago.
Cholesterol circulates in the bloodstream and then enters cells by receptor-mediated endocytosis. Instead of circulating freely, cholesterol molecules are derivatized and packed in.
Hey guys, and welcome to today's video. We will talk about a variety of cell signaling possibilities, cell communication, and about different cell signaling types. Here we start off with paracrine signaling. The blue cell can release growth factors, for example, and all the surrounded cells here with the expression of specific receptors can now bind this ligand. This can then activate intracellular signaling, for example, some downstream effects like gene transcription activation. However, cells in the near surrounding with no expression of this receptor, they cannot be targeted for communication. It is important to mention here that for paracrine signaling, the cells have to be in rather close range. The signaling molecules released by the donor cell here.
So that close range, how close is that? Is that based on the diffusion? Closely. And like the act of nearby cells, its local neighbors, typically reaching them by diffusion. Damn! So it's the extracellular fluid. Like, see how weird my brain is? Like, I read the first sentence, then I immediately got like 3 questions. And I ask them without even reading, because this is answer number 1, this is answer number 2. and this is number 3. Like, that's crazy. It sits in the middle of spectrum of signaling ranges. Autocrine, the cell signals to itself, binds receptors on the same cell that release it. Paracrine, signal near. I need a diagram. Local diffusion. Endocrine signals distant cells via the bloodstream hormones. And juxtacrine signals via direct membrane contacts with the adjacent cell, Nach delta. That is so cool. I don't know if it's gonna be enough to. Autocrine signaling up to junctions, paracrine, endocrine. Where's the others? Science note. Autocrine. Security check. I'm a human. Yep. Endocrine, autocrine by itself. Endocrine, it's a hormone through the blood. Paracrine, multiple cells level. Neuronal synapses. Extracrine, signaling like cells to cell. Wow. Whoa. Elastic fibers. Fibrillary collagen type 1, non-fibrillary collagen type 4, nidogen, laminin. I only know lipids, cell membrane. Hold on, I need to get a baby. Back. We are back. What do we have? Code cow token with not block and barn and action bind not with. Why do we need node? Why do we need node, and especially that old node, not 20? No, I need to be on the latest one. But I don't think we even need node. Maybe for the player, yeah. So I think one of this missing, right? 1, 2, 3, 4. 1, 2, 3, 4. No, that's right. Okay. Let's print that for now. Cell surface receptors. I like this all. Let's go download. 1. Oops. 2. This is good. Lichtenberg domain. That's the whole, basically, right now, a lot of science innovation happening. Like, how can we deliver to cell so these proteins a different signal or drugs, and drugs probably not the right word for that. So what I'm thinking, we develop our own one that's react like geomagnetism, right? That's one of them. Let's react on our kind of custom fields and open and close at will. So we put a lot of stuff into the what's the name of that? Thank you, website. Merged. Extracellular fluid. Put a lot of concentration into extracellular fluid, and then we open the gates Great. What is next? Do I need to compact? YouTube Studio. Content. Live. Oh no. Wrong button. That's better. Next are merge PR3, green wait on you, hot token, driver player v2. Compact, not require all states is durable, PR merge. But yes, it's I'll start. I'll start a new dir, new session. Autocrine when cells signal to itself. Paracrine signals nearby neighbors within a few diameters of the cells, and it's a extracellular fluid. What types of there are? The reason the range says local is mostly biochemistry. Paracrine ligands are often quickly bound by receptors, sequestered by extracellular matrix proteins. Heparin sulfate proteoglycans, for instance, or enzymatically inactivated, so they never accumulated far from the source. I didn't really get it. Classical example relevant to development, which is where the paracrine signal really shine. Morphogenesis. Bypass permissions for this session. Like Sonic Hedgehog. What? Don't give me examples like this. I never watched that movie or like cartoon. A source cell secretes them and they form morphogenesis, and they form a concentration gradient across a tissue. Cell reads a position based on local concentration and choose a fate accordingly. These have a not short patterns, the natural tube into motor neurons, interneurons. I think that's how multiple cells deciding that they are becoming this kind of fate from stem cells to these cells, and dictate that two neighbors. Regular preference wound healing and angiogenesis. Ugh. Cringe. So many words that I have no idea what that means. I need to set a timer, 13 minutes. Cytokinesis and chemokinesis, an immune response where one active immune cell tells neighbors to wake up. Neurotransmitters as synapses are typically perceived, so synapses cleft is the conceptual. How close do the cells to be? Typically, paracrine range is micrometers to a few hundred micrometers. For context, a typical animal cell is about 10 to 20 UM. No, that's not a UM. Micrometer. So UM it's micro. 10 minus 6 meter, 1 million of a meter. Micro, okay. Reach anywhere from immediate neighbors out to maybe 20-30 cells diameters away. Okay, some concrete numbers, very short range. Nitric oxide, some growth factors. Embryonic morphogenesis, like long range paracrine. So this is interesting. I actually want to chat about it with this. I want to start one more session. Let's brainstorm. I'll ask questions, and you based on code base and road map will tell me how feasible is that. I'm not sure if this is good. I would say yes. So number one. So cell has a different communication, right? It's autocrine, paracrine, endocrine, justacrine, and so on. So the idea is the concentration of certain I would say proteins or enzymes in extracellular fluid, and those getting bind to the cell membrane proteins and signal. There is different types how those proteins signal to the cells themselves. So that's kind of more into chemistry. But in our case, we do need to establish signaling. That's the most profound idea of the whole simulation, that we can apply any signaling from outside extracellular fluid to our cells. And I believe right now we set up that as a field, but we set up field as an array or matrix, and I don't really like it. I also think it's gonna be many different fields. For example, like different concentration of different concentration of different signals. Again, obviously it's a gradient, but we're gonna have different. I would like to represent concentration as a fields, and we're gonna have a array of fields, like hundreds, maybe thousands of different fields within our cells simulation. And those fields will be obviously dynamic. Some of them not long-lived, some of them short range, some of them long range. So the any signal I would like to represent as a field, but the field itself I would like to represent as a vector, not the array. That will save us a lot of space in a file, and we can calculate concentration dynamically by the cell position and the vector of that field, intensity of that concentration by just multiplying the vector. That way we can, for each cell, we can calculate what is a scalar concentration at any given tick of any field. But the big win there is the way how we're gonna store that field. We're not gonna store it as a matrix, but we're gonna store it as a vectors. And I think that will save us a lot of time, and it will also give us ability to have like hundreds different fields, because each field representation of concentration, let's say barium, or concentration of natrium, or concentration of certain proteins or enzyme within our world. I don't know if it understood me, but we'll see. I really want to I need to get the latest. No. Yes, that's signaling. Install not latest 3 node. Yes. What governs the range? It's competition between how fast the molecule spreads and how fast it dissipates. There is a clean equation that captures this, where lambda is the characteristic decay length of the gradient, d is the diffusion coefficient, and k is the degradation rate. So 2 mark snaps. Perfect. Yes. Dude, that's exactly what it is. I just read it. Yes. Decay length. UNC. Okay, clip that. You are inside real biology. Ta-dam! Day 22. I'm dropping real biology. I'm just kidding. I'm still learning. It's only 22 days. Like, current fields map string velocities in numeric PDE solver. Each tick injects secret, diffuse, explicit Laplacian decay on the whole grid that stores HWD float per field, evaluates it step by step. Terrible. This is like 500 megabytes. Your vector, not array, the analytics fields don't simulate diffusion, store the source, and compute concentration on demand from a close from kernel. Yes. Turns out a point source emitting constantly with diffusion d settle static gradient. Decay length, that is your range number. That is directly. No, so this is how dev-bio actually parameterize morphogen gradients by coed exponential wall pair. Oh my god. So a field equals small param tuple per source. Pose amplitude as lambda. Concentration at cell sum of kernels over sources. Not literal multiply of one vector. Superposition of distance kernel, that's correction matter many source, equal integral, not a dot product. My brain gonna explode right now. Win real, win storage, space source, tuple list bear, live field shrinks heart, live file shrinks. I like this. Hundreds of fields, each field's cheap, no grid per field, loves this. Range per field free. Now biology sortion. First abstraction, flow better, close form rate, no kinetics, march, current explicit yes. Collisions, flag now, transient, grid capture history, bloom, spreading, sloshing. Boundaries. Newman wall, trivial on grid, clumps neighbors, and kernel sources, turning, diffusion and forward map. This is a killer. Turing, nonlinear reaction diffusion. Turing parents are emergent from a nonlinear couple figure. No close form exists. Throwaway grid can do Turing. It's explicitly on your milestone list. Side note, Turing also smells like chemistry kinetics. Your abstraction flow rejects. So roadmap versus flow already in tension. They're independent of this. Warsaw biology check pass. Bioelectric Levin obstacles. VMEM spread. Diffusion blocked by tissue. No closed form once geometry blocks pass. Grid handles naturally. Why it's in the CI? I thought it's a different session. Hi, analysis gradient is textbook. First floor. Effort medium interface panel field imagine source boundaries and web roadmap fit. Partial grade for paracrine and endocrine morphine gradients cannot replace grade for tuning by electric through tissue, so fabric not replacement. I'm not quite understand why roadmap fit is partial, specifically why do we need a grid for bioelectricity? Can you explain me in a more simple examples or simple words? Like use geometry maybe? Basic English? We are brainstorming right now. Like the whole, all who these sessions, don't ask me like commit or anything, we just brainstorming. Don't modify files, we brainstorming and we will produce plans. There's another agent who is doing modification in the source code right now. We install latest node. Where is my analytic fields work when concentration at a spot equal formula of distance from the source. Know how far the cell sits from the source. Plugin done. Source shuts into open space. Loudness fades within distance. Yes, grid needed when that sentence breaks, when concentration is not just a function of distance. Bioelectric breaks it. Bucket, brigade, not shouting. Picture cells as people standing in a room. Chemical signal, analytics okay. One person spread perfume, everyone smells it by how far they stand. Spray travels through open air, distance stress formula. Bioelectric grid needed. Voltage does not flow through the air, it passes through hands on. So, people who are physical, holding hands, gap junctions, little tunnels, join touching cells. Bucket, brigade. I think we've already been in a 3 or maybe 4 side quests. 3 for sure. I need to pick up my daughter. I'll be back. Okay, we are back. So for bioelectricity, we're gonna use different stuff, not a grid. We're gonna use different data type. Definitely not a grid. I also want to specify this. Turing breaks it differently, feedback loop. Strength of the cell depends on who is connected to whom. The geometry version analysis as the crow feels, deriving distance through the actual rows. If rows twist and bridge is out, straight line distance lies. You need the map and you trace it. So for sure we govern this by regarding bioelectricity, we will use different data type, maybe chain link, something like that. Ignore it for now. Definitely not a grid. It's not the right presentation. Optimal to represent city. The reality. And why it's using different sessions. We can meet into same actions. Consider radius 1 volt unit schema, radius here, distance, local node pinned to latest CI node. Yes. Hold on. I still want to install a proper node. Not the proper. I'll close the session. Node. The nvm list Krypton. I want to go at least to the Krypton, right? What is the most stable node? (2214) nvm use. Damn, that's remind me. v24 nvm install v24 that 14 that 1. NVM use v24 that 14 that 1. I install node 24.14.1. Please use that. Yes, we do need CI CD and push it to that PR. Oops. Honestly, that's a different one. I'm gonna read it here. Hans, you're right. I was sloppy lumping grid graph. Let me split clean. Yeah. I am done. Key dominant, yes, and the catch. A grid lambda is the 1 ampere field. D is the small molecular physics. Slow lever. K is what cells actually control. Fast lever. Proteases. Receptors uptake. ECM. Heparin sulfurate grab. Decoy receptor. So in the sim you expose lambda, or D and K split per field, and K is where biology lives. What? But I was right. Just kidding. Yep. But your own philosophy not hides a fork. Uniform K, proteases, ECM everywhere, well mixed. K constant in space, clean radial, CR. C multiplied by E in minus R lambda divided by 4PD multiplied by analytic hold grade. Discrete sinks. Receptors on specific cells is the ligand. K is limpy, sits where the cell sits. Shadowing. A wall of receptors bearing cell between source and target soaks the signal like a sponge. The fast cells get less than distance. Alone predicts. Radial formula now lies. So receptor mediate degradation in the same paths matter. Problems sneaks back in V1 answer. Uniform K per field, clean kernel, document the limit. Later, discrete sync as local correction, not a blocker, non-H. I don't like the uniform K. Bioelectric grid is one, you're right. Yeah. Reality check where the grid loses, graphs wins. I'll define it, not flatter it. Defend it, not flatter it. Bioelectric is circuit, not a fall. Carries a bucket bridge forward. Not cells already have cell NVM. Edges gap junction, the hands of edges. Update current flow along edges by voltage difference. That gap Laplacian C network, not a special on lattice. When lattice grid is wrong type. Concretely. I would like that to be link chains, like let's take one equation as a die. let's solve K and then go into brainstorm for biodiversity. So for the K, I don't think I ever meant it should be constant. Like, explain what K is. What does K represent? I like your example with a room of people. Maybe try that. I need this. Enemy. K, how fast the signal molecule disappears. A removal rate unit 1 per time per tick. That's a decade. Should be decade of the signal itself. Is the site of the balance decay the molecule out, deletes it. Spread the molecule out, K deletes it. Range is a tug of war between them. First order clearance means every molecule has the same chance of being removed each tick, no matter how many there are. Like radioactive decay half-life. Big K short half-life molecular dies, young short, small K molecular ligand drift long range. Okay, room of YK not constant, and you are right. ECM all sits around the cell. Someone spread perfume in the corners. That's the how fast the smells differ across the room. Air carrier molecule size K. Air purifier running in the room, sucking perfume out of the air. Many purifier big K. So how to model K? K is its own cell-divide field, cell-driven field. Each cell contributes local removal proportional to its receptor protein MC total K at point. So it's very important that K should be defined, and it should be bound to the decay, right? Because some signal half-life of those proteins or enzyme, it's actually a few minutes. For another one, it's a few days. So if we put certain drugs into a petri dish, the K would stay probably hours or like even days. Depends what it is, right? So the K should be defined on a field level, on a field object. That's number one. And K is different for different fields. For example, for gross carbon, it's 1K, and for some kind of field that created by B cells, immune cells, it's a different number. The K is a different number. And the fields, they live kind of their own life. They just toggle war between time ticks, decay, and the distance from where it spreads, right? And obviously the gradient of amount of that signal. But there is another thing, that cells might not have receptors to accept that signal and could be completely ignorant to that field. Therefore, the signal gets into the cells only if field is present and enough concentration around the cell, and also if the cell has receptors for that. So the cell should have a list of fields that it can intake with the concentration, because, for example, it might have a lot of receptors to get signal about growth and very little receptors to get a signal about some kind of immune system, right? And when we multiply or sum those signals, that will be a product of or result signal in a cell that can then influence our genes or influence our cell machinery to do something else, to do some action, to trigger a function when certain threshold is reached, right? Again, we should stay away from chemistry, but we should have a pluggable system that we can add any field. Let's say I want to add a solution to the Petri dish. I will represent the solution as a field with certain K and concentration, and then I will also make sure that the cells has receptors for that solution. So I'll represent that as the cell fields for intake, so signals. That way we can cover all 4 different types of communication. Autocrine, paracrine, endocrine, and juxtacrine. Maybe not juxtacrines, but you got the idea. We'll see. Okay. The IMSI is the ruptural part. I didn't see my message. Where is my message? Yes, K belongs to on the field. You just drew the cleanest line yet. Let me lock it and resolve the loose and from last rank. Yes, perfect. K equal field property, not cell property. Perfect. K is the molecular own half-life. Yes. Yes. Clip that. That's what I want. Interaction shows the substance, so on the field object, drugs that's last days, tiny cake, guns. Okay, 1 unit gacha. K is per tick, so you must pin what tick is worth in real time. If yes, it's this is so true. This is so true. A drug with an per tick, basically immortal in a short run. Exactly, you saying hours and such. Put a real-time per tick somewhere explicit, or half-lives become meaningless number. That's so true. Let's think about it. I have so many questions. I don't know in what order to ask them. The loose end resolves itself. 2 vacuums, 2 owners. Last turn we hit is K uniform or limpy? Your receptor idea answered. There are 2 removal paths and they belongs to different objects. Yes! Clips that. That's exactly what I mean. Decay molecule breaks down on its own parenthesis, spontaneous, field K uniform. Yes. Uptake a cell with receptors, binds and swallows it. Cell receptors count limpy where the cells are. Perfect. So you were right both times. Da 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 da. Clip Z. Field K is a constant background half-life. Receptors and local removal. I honestly don't know how I keep track of what happened. Only in the day 22, I'm arguing with AI how the cell biology should work. There's 2 possible chances or outcomes from this. Number 1, I start to understand what the hell is happening there. And number 2, I'm so delusional. We'll bet all our money on number 1. Field K is a constant background locals removal type automatically you don't model. Sits on cell you don't model. Special variant K as a separate things, it falls out of receptor list for free. Curious that the receptor is both the ear and the vacuum. Yes, receptors is the ear. 100%. I'm not sure about the vacuum. A cell bindings is legend both here and they removes it. Oh, I see, yes. From the medium. 1 object, 2 effects. Yes, V1 choice to pin, do receptor removal signal or only listen. Listen only is simply and skip the field cells feedback. Add uptake removal later. Your call. Okay, so let's answer that. What is this? V1 choice to pin to receptor remove signal or only listen. Listen only is simply and skip the field cell feedback and uptake removal later. Listen only for now. Create a good to have directory and place the element that would remove sim a see that will explain that vacuum removal of signal and listening would improve sim accuracy, but for implementation we need to calculate compute versus effect. Does it really move the needle? Send. Where did I send it? Don't tell me it's here. No. Here? I'm gonna disable for this session. Disable. So I'm losing track. Let's answer that one more time. For this, do we listen only for now and create a directory good to have and create an empty document there that will describe that by vacuuming signal, not just listening but vacuuming, it will improve simulation accuracy, but might not worth it because the effect is not big enough and doesn't move the needle compared to amount of compute that we will use for that vacuum effect, removal of signal by listening, vacuuming. But for now, set that's the cell just listening, not vacuuming. There are more maps out. Disable sessions. Is it for this? Yes. Decision now agent readme server listen on this. Oh yeah, I put it wrong. I put the prompt into wrong session. Please ignore that. That was not for you. Right, we are concentrating on the player here. Should I roll back the session? That's what happens sometimes. Oh, the receptor maps onto the locked flow exactly. This isn't new architecture, it's materialized the abstraction flow you already locked. Protein entities typed by function include receptors and ligand. Here, field, ligands, concentration, landscape over space plus time. Receptor the cells type enters that reads one field. Okay, sense input one field. No receptor, 0 Celsius. Lost growth receptor, few immune receptors. Here's grow loud immune faint. The product is rate proxy. I like that. Stay off chemistry. Love this. One guard the rail. Keep it linear, X and the threshold. The moment you reach for binding constants, heal curves you're lost into kinetics for bits.
Клетки кого? Окей. О, умные мужики сидят, думают. О чем думают? Смотрят на твои клетки? Они смотрят твой стрим. Как, ребят? Да, ты как бы-
Я себе аудио сделал.
О,
Я с ними участвую.
да. Смотри, как они
Ты
наблюдают.
там не дочисть. Бумажка 1500 шейдов. Некоторые по 4. Узнаешь?
Да.
Кто это?
Блин,
А, на Google Map написано.
так я не читала. Это... Ты за Глорией когда едешь? Езжай в 5, попарься.
Давай микрофон выключу сейчас. Okay, we're back. We need to clarify a couple of things. Sense input for one field, sense F, concentration F, receptor F, no receptor 0, yes. Two things this quietly buys you. The bridge to genes that sense vector across all fields. The input layer to the express phase. Sensed F values, gene regulation action at threshold. You just specify phase 3 input. Why it buys you? I don't understand these expressions. Like, why you... Who is buying me? Is an idiom used to describe an investment, such as phases, habits, or lifestyle. Okay, that's good. Receptor, yes, perfect. Receptor profile identify what feels clean can here is part of what makes cell type. Liver cells immune, yes. Please remember that and save it into our roadmap. pluggable. Drugs and solution are just fields. Yes, this is exactly what I want. You add a solution to the dish, register a field with the K concentrations, and decide which cells carry receptors for it. Yes, clip that. That's exactly what I tried to explain. Nothing special case that the pluggable system and the same shape of the fields in our outside. The 4 communities types. Yes, this is exactly what I mean. Please autocrine cell emits field and has its own receptors here itself. Paracrine emits neighbors with the lambda health receptor circle. Endocrine low K huge lambda distant cells with receptors here. Here it's semantic. Just acrine does not fit. Contract only, not delta, no diffusion, no distance. You sense that, maybe not just endocrine, you get the idea. Just acrine is a graph H. Signal pass only between physically touching cells, same structure as cytonyms and bioelectric, so 3 or 4 are fields. The 4th is a graph. Clean seam, just acrine writes on the bioelectric brainstorm next. Want to pin the 2v1 choice now receptors, listen real time per tick, or move to the bioelectric. Alright. I need to define this. This. Yeah. So let's define this. It's a very critical decision. Give me options and pros and cons. When I appear document real biology before build next binary reference on when ready. M3, so we have reward works with clean, both readme binary good to have, removed receptor prompts left not trace, player and touch, CI green, we will still focus on the player here. Go is next. Critically, as this real multi-scale decision in disguise. Biology spans 9 order of magnitude in time. Ion gate in milliseconds. Signal in sec. Transcription mean. Protein half-life mean days. Cell cycle hours. Development weeks. No single ticks results all of it. So the real question underneath, what time band does the sims live in, and what gets abstracted away above and below it? I have ideas, very interesting ideas about it, but I think I will leave it for the next stream. See you then. May 23, see you soon.